Multiple devices can be connected to the I2C bus. However, only a master can start a data transfer. Whether that data transfer is a write from the master into a slave device or a read from a slave device into the master. So let's take a look at how that protocol actually works. So we're going to start by saying a data transfer is usually done on a transaction basis, and a transaction might have a byte, 2 bytes, or 3 bytes. The protocol doesn't specify how many bytes do you do per transaction. So let's take a look at two examples. One is a write transaction, the other one is a read transaction. I'm going to start with the write transaction and how it works. Generally speaking, the bus is idle and a master wants to write into a slave, and it starts by saying, okay, I want to put I want to take over that bus, so I'm going to initiate what we call a start condition. So it puts a start condition in here. We'll see the details of what a start condition is. But basically, it just says, hey, I want to take the bus, and it's put something on that bus to take it over. Next, because I might have multiple devices and you need to know which device you're communicating with, you actually need to provide the address of that device. So we're going to say that it's the slave address, and generally speaking, it's 7 bits. Okay, so 7 bits, that indicates that we can connect up to 128 devices on that bus. In addition, you don't only send these 7 bits, you also send another bit, which we call a direction bit. So if you put a 0 on that direction bit, it indicates that you want to write into that slave. So you're indicating which slave you want to communicate with, and you're indicating that you want to write into that slave. So what happens is then the slave actually acknowledges by placing a 0 on the bus, saying, yes, okay, I'm activated, I'm ready, you can go forward with it. So just a quick note in here, whatever you see is in white is actually usually the master transaction, or it's coming from the master to the slave. Whenever you see, or whatever you see in gray, it's actually coming from the slave to the master. So the acknowledge comes from the slave to the master, so the master reads it. Next, after the master have taken the bus, it indicated which slave it wants to communicate with. It actually can put on the data bus whatever it wants the slave to actually get. So it puts an 8-bit or a byte on that bus, and then after the transfer basically gets, like, remember it's one bit at a time. After the transfer happens with different clock cycles, exactly 8 clock cycles, the 9 one would be an acknowledge from the slave that it actually received that. And you can repeat that for as many bytes as you want within a single transaction. In this case, I'm just showing you a couple of bytes in here. So a second byte gets transferred, and then the slave acknowledges, and then the transaction is done. So what the slave does, it actually stops by putting a stop condition in here, which means that the bus is now available for any other transaction or any other slave or master to actually take over. So this is how a write transaction happens. A read transaction is extremely similar. So the master puts a start condition, then puts the address of the slave, and then instead of a 0, puts a 1, indicating that I want to read from the slave. The slave acknowledges that, yes, I'm ready, but then what happens is the master is actually receiving. So that data byte is coming from the slave. The master actually reads it, and once it reads it, it actually acknowledges. And by acknowledging, it's actually meaning you actually put 0. When you acknowledge, it's actually a 0. And you keep repeating for as many bytes as you want. Most importantly is actually the last byte in here for the read, because you want to tell the slave to stop sending you data. So the last byte you send, and in this case actually the second byte or the last byte you receive from the slave, you actually put, instead of an acknowledge, you say not acknowledge. Basically, you just tell it it's a 0, and the slave knows that, and it just stops. And then you put a stop condition on the bus, and you release the bus. There's also another signal in here, which is actually a restart or a condition. A restart condition is not shown in here, but as it happens is, like, if you put a stop condition, whether it's here or here, you relinquish the bus. But there are certain devices that you actually need to write and then read, or read then write, and you don't want to relinquish the bus in between. So what we have is, instead of doing a stop, we will put some sort of a restart, and the restart basically goes in here, and you don't have to put a start, you just basically start the second transaction. And in this way, you don't relinquish the bus.